Hello students, I hope that you are good, well and fine. Today what we will be seeing the derivatives of functions but in of the forms of parametric form. Okay, you will see that what do we mean by parametric form and how we do derivatives of those functions in the parametric form. Okay, so let's right jump to our first thing, which is our outline for this session, which is the main objective or the sole purpose for this session is to get to know about the parametric form and how do we do the derivatives of those forms. So sometimes the relation between two variables is neither explicit nor implicit. So far we have learned about explicit function and implicit function. Explicit function are those function if you have a form like y is equals to some expression of x. Okay, this means x and y can be separately written. Okay, so that's why it is written explicitly. Implicitly means you cannot, there is not an easy way or there is no way that you can separate your x and y. Okay, so that form we will call them as implicit function. And now the third type we will be seeing is parametric form. So what, but so here the relation between two variables is neither explicit nor implicit, but some link of a third variable with each of the two variables separately establishes a relation between first two variables. In such a situation we say that the relation between them is expressed by a third variable, that the third variable is called the parameter. We will calling the third variable as a parameter. Okay, clear? Okay, so let's see more precisely what we are talking about. If a relation is expressed, more precisely we are talking about if a relation is expressed between two variables, what variables x and y, in the form, what form, that x is equals to some expression of t and y is equals to some another expression of t, then we said that this form is parametric form. With what parameter, what third variable we are using t as our third variable, so t will be our parameter. Okay, t our parameter. You will see some examples, you will see what do we mean by these. Okay, I hope that it is now clear what do we mean by parametric form, what do we mean by parameter. Okay, simple. Okay, let us move next. Now how do we getting our derivatives of such forms? Very simple. In order to find the derivative, we have chain rule. We will apply chain rule, but in what manner we have to apply our chain rule? Okay, so think. Okay, so let's think. You have to find this dy over dx. Obviously, every time what you are doing, differentiating your y with respect to x. That's what we want. Here we have x in terms of t and y also in terms of t. Then how do we find this dy over dx? Very simple. The first task is to find the dy over dt, as you have the relation in between y and t directly. So how you can directly find this dy over dt? Very easy. Dy over dt you can directly find by using the relation given. Now this dy over dt can be written as dy over dx multiply with dx by dt. As you can see, this will be get cancelled. That's why we can easily write it like this. Okay, or if so this means you can say what's doing some manipulation. You will see that dy over dx means dy over dt divided by dxy over dt. You know this form, as y is already in the form of t and x is already in form of t. Okay, obviously we want this thing to be happening. We do not want our denominator to be 0. Simple. So using this simple fact, this simple chain rule, we can get our dy over dx, which is in the form where y we got what we took. Y is just nothing, gt. If you remember, y is your what, gt. Y is your what, gt, and x is your what, ft. So derivating dx by dt will be f dash t, and dy dt will be g dash t. Okay, clear? Okay, so that's what it is written over here. Dy over dt means g dash t, dx over dt means f dash t. The simple thing we have already written. Obviously this form means f dash t will be non-zero. Clear? So I hope that this whole thing is very clear to you, how we are going to find the, first of all, how we will say that this a given form is my parametric form, this given form is my implicit form, this given form is my explicit form. Okay, and according to that you will apply the respective or the corresponding rule, theorem, whatever you just learned. Okay, so in today's session we will be mainly focusing on parametric form. So what do we mean by parametric form, how it is related, how we are going to get our dy over dx out from the parametric forms. Okay, clear? Okay, let us move to next. So let's see some examples. So as x is equals to a cos theta, y is equals to a cos theta. Now we have two variables already, x and y. Okay, there is another variable. Yes, here we do not have completely clear idea that we take a as our variable or theta as our variable. Okay, so this thing is hidden, obviously, that a is our constant, not theta. Okay, sorry, a is our constant. A is, we are taking as our constant term. Okay, a is our constant term. So this means the parameter in this relation will be our theta. Okay, parameter is theta, so that's why we will say that this is my parametric form, as theta is my parameter. Okay, and one more important insight is, if you remember, x is equals to a theta, sorry, x is equals to a cos theta, y is equals to a sin theta. This is what form? This is what parametric form, if you remember? Yes, this is what parametric form you remember? This is for circle. Yes, x is equals to r cos theta, y is equals to r sin theta will give you the circle. Okay, so this is just nothing but the circle. Okay, what circle? With radius a. Circle with radius a. If you do the square, you will get what? X square is equals to a square cos square, y square is equals to a square sin square theta. So if you add x square plus y square will give you what? Taking a square common, cos square theta plus sin square theta, it will become 1. So x square plus y square will give you 1. This is just nothing but your circle with center 0 0 with radius a. Okay, so please keep this extra information with you. This will be very beneficial in future also. Okay, in future exam perspectives. Okay, clear? Okay, now how we are going to find the dy over dx? The same approach we will apply. What approach? This thing. So we will do, so first of all we have to find the dy over dt and then dx over dt, and then solve this. You will get your dy over dx. Okay, simple. Okay, let us move. So let me just show you. So dx over d theta, so here parameter is theta, so dx over d theta means a is constant, we are taking a as constant, so this means minus cos differentiation derivative is what? Minus sin theta, so minus sin theta. Now dy over d theta will be what? As a is constant and sin theta derivative is cos theta. Now dy over dx will be just this thing, divided by the dx over d theta, this thing, you will get this as minus of cot theta. So the answer for this will be minus of cot theta. Okay, simple. Okay, let us move to next. Now seventh problem, sorry, now let us see some another example. Here we have given another example. So again, here if you choose the t as your parameter, yes, a is our constant, t as our parameter, so this will be your what, parametric form. Now how you find this dy over dx? Very simple. Okay, let us find that. So dx by dt will be what, 2at, just 2at, and dy dt will be what, just 2a. Now dy over dx will be what, dy over dt divided by dx by dt. Okay, 280, so you will have 1 by t as your answer. You will have 1 by t as your what, as your answer. Okay, simple and clear. Now if you try to think one thing, which is what, t, you know that t is just nothing but y by 2a. T is just nothing but y by 2a. Now what will happen? X is equals to a, what is t? So it will be y square by 2a square. So this and this will be cancelled. So it will be this thing. Okay. Now how you are going to find this? Very simple. So this is your implicit function. So 4a is equals to 2. Okay, 4a is equals to 2 y dash. Yes, 2y dash. Now this will be what, 2a divided by y, and y is what, our, if you find from this, y will be in some root. So in this manner you can also find your derivative. Okay, in this manner you can find your derivative. Here the one thing is very clear, that here you are getting your t. Here you are getting your t, so we have to substitute it. In previous, I think I haven't substituted in the previous form also. So this will be substitute t value in terms of y or in terms of x, whatever you want. So I am choosing this. So it will be 1 by t will be 2a by y. 2a by y. T will be what? T will be 2a by y. Okay, simple. Okay, clear? Okay, so you will have this dy over dx as this. Okay, so I think what I am doing, if you derivative, it will be 2a by y, na? Yes, if you cross multiply derivative, yes. So you are getting the same form. Okay, you are getting the same form. You are getting the same form as this. So use this information or use this method, you will get the same answer mostly. Okay, in the previous, let me just do it. We haven't substituted. So what we got, if you try to see, this will be after substitution and dy over dx using this, we got minus of cot theta, I think. Okay, minus of cot theta, replace theta by any of this. So if you, theta will be sine inverse of ay by, you can also do that. Okay, clear? Okay, simple. Substitute this, you will get your theta replaced. Okay, simple. Okay, or what you can do, not just replace, let me just once again, so dy over dt, dy over d theta was a cos theta, and in denominator we have minus a sin theta. So this means what? This means minus cot theta. Now we have to find the cot theta. We have to replace the theta. Obviously we want some x and y. So just do what? Y by x. If you, sorry, x by y will be what? X by y. What is your x by y? X by y will be a cos theta by a sin theta. This means cot theta. So you can replace cot theta by x divided by y. So your differentiation will be this, or dy over dx will be this. If you find using this information, then you will get 2x plus 2y, y prime will be 0. This means y is equals to minus 2x by 2y. This means x by y, minus x by y. So yes, we are getting minus x by y. Yes. So use this method or use this method, you will get the same answer. Okay. So please do not forget to substitute your parameter. Okay. You want your dy over dx in terms of x, in terms of y, or the combination of x and y. Okay. Simple. Okay. Let us move next. Now this problem. Same, dy over dx will be what? Dy over dx will be, as you can see, it will be dy divided by dt. So dy divided by d theta you will apply. So a 1 plus cos theta, it will be 1 plus cos theta divided by, and this will be a 1 plus sorry, not, let me just explicit separately evaluate them. So dy by d theta will be a, okay, taking a, okay. Now one derivative is 0, this will be sin theta. Yes, it will be sin theta. This can be rewritten as this form, and this will be derivative, this will be 0 minus a sin theta. Okay, yes, so yes, so it will be a sin theta divided by, and this will be 1 plus cos theta, 1 plus cos theta. As you can see, it will be sin theta by 1 plus cos theta. Okay, so far so good. Now how you are going to eliminate these thetas? How? So let me just think. So one thing what you can do is that okay, clear. So how you can separate this? So first of all, let me just simplify it further. You know, this will be sin theta by 2 cos theta by 2, and in denominator 1 plus theta, you remember, would be 2 cos square theta by 2. So this will be 2 cos square theta by 2. This 2 and this 2 will be cancelled. This cos will be cancelled. This will be tan theta by 2. So this will be tan theta by 2. So it will be tan theta by 2. I think this is clear. Okay, now how we are going to replace tan theta by 2? Okay, let's see what combination of x and y we can do. So one what is just try to square them. Yes, okay, try to square them, try to replace the tan theta by 2. How we can get tan theta by 2 replaced? Let me just think. So you know 1 minus cos theta, you know 1 minus cos theta. Yes, so this is just nothing. If you try to see what is happening, 1 minus cos theta is just nothing, 2 sin square theta by 2. Yes, 2 sin square theta by 2. Okay, 1 plus cos theta is this, 1 minus cos theta is this. What is happening is there. Okay, now what you will use? As you can see, I want tan theta by 2. I want tan theta by 2. Okay, so how I am going to get it? it is very simple, very easy. So you have to just give some thoughts. You have to just give some thoughts. So what thoughts you must form? So what thought you must form? So the thought will be coming to your mind will be a very simple thought. Okay, very simple thoughts, and those thought will be what, as you can see, let me just write it for you. So tan theta by 2 we are having tan theta by 2. Now what we will do is just, so this 1 minus, if you try to see, this will be 2 sine square theta by 2. Yes, 2 sine square theta by 2 is equals to y by a. Okay, is equals to what? Y by a. Now what you can do is that if this is happening, this means that it will be sine theta by 2 can be rewritten as, okay, sine theta by 2 can be rewritten as what? Y by 2a root plus minus. Yes, y by 2a root. And now we know what we know. By using this property, I can directly find my, so this will be root y, this will be root a, then this will be what? Square of root of square of this minus square of this. Now this means tan will be, tan theta by 2 will be either plus or minus, then it will be root y by root 2a minus 1, or what? Root y by 2a minus 1, this form. You can write in this form. Okay. Or if you want to try another way, please do so. You will get this answer. Okay. I hope that it is clear that how we got it here. So this part was a little bit tricky. Okay. But don't worry. You have identities, trigonometric identities. You have formulas. Okay, use those and you will get your final answer without any problem. Okay, okay, clear? So far so good. Now let us move to next. So note one thing is very clear. It may be noted that dy over dx is expressed in the term of parameter only without directly involving the main variables x and y. Okay, clear? So as you can see, we just want our dy over dx in terms of x and y, but here this note is saying that it may be noted here. You can also leave your answer as that dy over dx is expressed in terms of parameters only without directly involving the main variable, okay, x and y. Okay, clear? So you have both the choices. Okay, let us move next. Now differentiate it. Very simple to differentiate. So differentiation of this will be 2 by 3 x power minus 1 by 3, okay, plus it will be 2 by 3 y power minus 1 by 3 y derivative, which will be 0. This means y derivative is equals to, if you try to see, x minus, so minus of x power minus 1 by 3 and minus 1 y power minus 1 by 3. So this will become just nothing but y by x whole power 1 by 3. So your final answer will be this. So your final answer will be this. Okay, I hope that it is clear. We just use nothing but the x power n derivative is equals to n multiply with x power n minus 1. Okay, so a was our constant, so that's why its derivative will be 0. Okay, now let us move next. This thing, how we are going to show that dy over dx is equals to minus y over x. So very simple. So first of all, find this. Dx over dt will be just nothing but 1 by 2 root a sine, let me just write it clearly. So 2a power sine minus t, and this will be a sine minus 1 t log a, will be multiply with the what, the inside thing derivative, which is this, and then again sine, so this will be 1 minus t square. Okay, now dy over dt will be 1 by 2 root of a power cos inverse t, and multiply with the derivative of inside thing, which will be a cos inverse t multiply with log a, then again multiply with the cos inverse derivative, which will be minus of 1 minus t square. Now what you have to do, dy over dx will be divide this thing by this thing. You will see what will be cancelled, this and this will be cancelled. You only left with, let me just write it for you. So this thing, okay, let me use different color. So this thing and this thing will be cancelled, but minus will be there. Okay, now log a and log a will be cancelled. Okay, this 2 and this 2 will be cancelled. So you are only left with a, so you left with minus of a power cos inverse t, okay, divided by root of a cos inverse t. Now multiply with, okay, so this will be what, so you left with a sine inverse t and root of a sine inverse t. Clear? And this will be what, you can remove this will be this, and you can remove this. Now what is this? Root of a cos, this will be your y, and what is this? This will be your x. As you can see, you showed that dy over dx is equals to just nothing but minus y by x. Okay, so that's it for now. I think this is the end for this session, as time is running out. So I hope that you understood everything, how we showed, how we use parametric form, how we evaluated our derivatives of the parametric form. Everything is clear in today's session. Okay, so okay, I hope that every step, every explanation, every concept we used is clear to you. So in parametric form there is nothing much to learn. The only thing is to do the proper differentiation, like in this form dx by dt and dy by dt, and put what, this dy by dt and divide this by this thing. That's it. You have to do this simple task in your parametric forms. Okay, and try, not always, if question is asking, then always try to put your dy over dx in terms of x and y. This will be very easy for anybody to understand. Okay, clear? Okay, so that's it for now. We will be back with the more theory and with the more questions of this chapter, continuity and differentiability. I hope that you are getting the idea what do we mean by continuity, what do we mean by differentiability. Okay, so thank you all. We will be back with the more theory and the problem part. Again, thank you.